Let's go to the next topic, point of use recycling for optimized space age logistics.
Hello, my name is Jeffrey Smith. I am the element architect for NASA's Deep Space Logistics project, and that's part of the Gateway program. Gateway is part of NASA's Artemis architecture, which will take humans back to the moon and establish a sustainable presence both on the lunar surface and in orbit around the moon. Gateway, as a part of the Artemis, will be a small human-tended platform orbiting the moon. It'll serve as a staging point for lunar surface missions and for science and technology demonstration that'll set us up to get a little bit closer to that first eventual human mission to Mars. Now, the deep space logistics missions are going to be the cargo missions to the Gateway, and they'll deliver supplies and payloads to support the crews at the Gateway, as well as support the surface missions to the lunar surface and other destinations in deep space. So as the cargo delivery people, our cargo missions for Gateway and deep space logistics are going to be a lot like the cargo missions for the ISS, the International Space Station. Cargo will have to be packed carefully. There's a lot of cargo packing materials and restraints that need to be used so that the cargo and payloads can withstand the high accelerations and vibration environments of the launch, and also during the transit period. Also, the cargo will have to be well organized so the crew can get access to the things they need and pack them away carefully when they're on the ISS or on the Gateway. It takes a lot of materials to do that, but there's also some very important differences between the way we're going to supply the crews for our Artemis Gateway missions and our lunar missions and the way we do it today on the ISS. Today on the ISS, we're able to send up a lot of cargo packing materials, and then we can take those out with the trash. The relative cost of packaging materials for delivery to low Earth orbit and ISS is quite a bit lower, at least an order of magnitude or 2 orders of magnitude lower than it will cost for us to send those same materials to the Gateway. So if we're going to begin in any way to create a sustainable presence in deep space, a sustainable human presence, we really need to take advantage of every single kilogram of upmass material we can. That includes the cargo packing materials. We don't want to throw those away if we can possibly have an alternative for that. And that's what we really need from you. We're looking for point-of-use recycling solutions for common waste streams that would be produced in space, particularly on the Gateway and as part of our deep space logistics missions. So we have this point-of-use recycling for optimized space-age logistics topic that we'd like to engage small businesses to help us understand the best way and the best choices to make for cargo packing materials that we'll use to send supplies and cargo to the Gateway. Then, once at the Gateway, we'd like to understand how we would recycle those materials into common useful items. The cargo packing streams, we think, are a very good starting point for this kind of full recycling capability because the cargo packing stream is relatively clean. It won't be very dirty. It consists of some regular materials, nylons for bags and strapping materials, some hard plastics for containers and cases that are used in the packing materials. Also, some softer plastic materials like foams. Ziploc bags are heavily used, and other types of plastic packing materials. Some styrofoam is also used. That's what's used commonly today. We're looking to see if there are better packing materials that are more conducive to recycling and being able to be, for example, broken down and then used in 3D printers, which have been demonstrated in space as useful for recycling materials. But there might also be other ways to recycle those waste products from cargo packing materials. There may also be ways to recycle other waste streams. We're very interested in paper type waste streams that could recycle paper products and turn those into something useful on the ISS or on the Gateway. And we're interested in food packaging type waste, potentially food waste, but we recognize that may be a taller pole and something for a future solicitation. So the point of use recycling for optimized space age logistics really looks at cargo packing materials for our Gateway deep space logistics missions as a starting point, but then we're interested in all kinds of waste streams and how to recycle those and make full use of every kilogram we bring to the deep space logistics missions and bring to the Gateway. Hopefully that's been useful, and I look forward to seeing more from you and understanding the best ways to have NASA recycle those materials and make use of them. Thank you.
Okay. Again, topic author did an excellent job. I think it becomes clear that, the more we want to go to space, the more we want to habitat space, the more have, the more we want to travel to space, the more we want to do things in space. The packaging becomes very important. We some materials or some science assets actually have to be packaged a certain way with certain types of packaging, such that we could perform tests in space. And that packaging has to be disposed of, in addition to the fact that we have food. And so these are various waste streams that must be dealt with. And we need creative ways to deal with those waste streams. And I think, again, it becomes very clear that also at home, our oceans are being flooded with waste. I think everyone has probably seen the pictures of the big trash pools in the oceans. They say the size of sometimes a few cities or even small continents at times. And so these are some of the reasons why we chose these topics, because these topics were very important, very critical topics, not only to us at NASA, but also to the United States and really the world.